Hello and welcome to this video on logarithms. We're going to take you through basics of logarithms and hopefully get you up to exam standard so that you know everything that you need to know for the Core 2 exam on logarithms. Okay, some starter questions for you. What you probably want to do at this point is to pause the video, have a go at the questions, and then return when you've got your answers. Okay, so I'll assume you've done your answers now. You probably want to check those off. The answers to those questions are anything to the power of 0 makes 1, and anything to the power of 1 is itself. So at this point, you're probably quite familiar with this set of rules here, and it's probably quite important that you do make sure you're happy with them before you carry on any further with the video. Statement here, the log statement, simply means what power of 2 gives us the answer 8, and we can see here that the answer is the third power of 2 because 2 to the power of 3 makes 8. So these two statements at the top are kind of one and the same thing, just written in two different ways. What we're being asked here is what power of 10 makes 100? What power of 3 makes 27? What power of 2 makes 32? What power of 2 makes a quarter? You will know about that from the work you've done in Core 2 on indices. And what power of 3 makes root 3? So if you have a go at figuring out what those powers and those answers to those log questions are all about, when you're ready, we'll move the video on to tell you what those answers are. And here are those answers. 10 to the power of 2 makes 100. 3 to the power of 3 makes 27. 2 to the power of 5 makes 32. 2 to the power of minus 2 makes a quarter. And 3 to the power of a half makes root 3. So moving on, we have some general rules to do with logarithms. Because we know that anything to the power of 0 makes 1, then whatever the base is, whatever power we're talking about, if the answer is 1, then the power must have been 0. So log of any base, if we've got the answer of number 1, the answer is going to be 0. Because anything to the power of 1 is itself, then log of any base of itself makes the answer 1. Indices are mad. When we multiply, we add. What we have here is we actually find out that if we add two logarithms together, then we can multiply those numbers. Similarly, if we're taking two logarithms away, then we divide, coming back to them same rules. Okay, if we're dividing with powers, we take away. So we're dividing, so it's a take away. If we're multiplying, then we add. So here's the multiplying because we were adding. If we've got brackets with powers, then we multiply them. So what we can actually do here is if we've got powers, then the power inside the logarithm can actually be brought down the front, and you can see it there. That's actually really convenient. That pops up loads of times in exams. You just have to learn to recognize it. So if you've got a number of logarithms, if that's 2 or 3 or whatever it is, then that will always pop up inside the logarithm as a power, a to the power of n. So this page is really your all-important page. If you're not quite convinced about those adding the logarithms and you multiply, dividing the logarithms and so on, just study this page here and convince yourself that you're absolutely happy with where this number of 128 comes from and why it's there. Similarly, this is our one with where the number in front of the logarithm pops up the top. Just convince yourself of what's going on here, and should that really be a 64 there, just make sure you're happy with that. Okay, so here's our first exam question. Now, for 1 mark, this first bit, what it's really asking us is we've got to work out what the power is. So here we are, they're saying a to the power of something makes 1. So what do we know? What sort of powers give an answer of 1? The answer is going to be that it's 0. Okay. The second one, we're told a to the power of something makes a itself. What must the power have been? It's got to have been 1, hasn't it? What this is based on, it's coming back to you, checking that you know these 2 rules. For our third question, we're trying to get the value of x this time. What can we do? Well, we've got 2 logs that are adding here. What do we know about logs when we're adding? When we add logs, we can multiply. Okay, I think there was a subtraction there, so I think we're going to be dividing for the other bit as well. Let's have a look. Log base A, 5 and 6, so we multiply them, so that'll give us 30. We've still got our log base A, 1.5, which we still haven't dealt with. Okay, so now let's do that. So now it's equal to log base A, 30, because we're subtracting, it's divided by 1.5. Put it in brackets just in case. Okay, so that just leaves us, if we can work out whatever that is what the x is going to be. We've got log of the base A of 60 divided by 3, so that matches with log to the base A of x, so therefore x must be 20. What have we got? Write down the value of x. Come back to them rules. Subtractions, you divide the 2 logs. That's going to be equal to log to the base A of 16 over 2. Now that is obviously equal to log to the base A of 8. Now, we don't care what this base is actually, because all we've got to match up is match up that bit there. That must be what matches up with that bit there. So we can finish off by writing x equals 8. 3 marks again. Express y in terms of a. So we're looking for something y equals blah 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 involving an a in there. Giving your answer in a form not involving logarithms. 2 times log to the base a of 3 plus, there's our power's going to jump up there. We're adding so we can multiply, and we've got this thing, which isn't a logarithm. That might cause us problems. If it's going to be 1, could we replace that with a logarithm? We're talking base a's, aren't we? So we're going to have to match the base. So we can replace that 1 with log base a of a. I'm going to write the whole thing out. Log to the base a of 3 plus log to the base a of 4 plus, I'm going to make that substitution. So this is log to the base a of a. Now let's start sorting things out. Right, 2 is going to go up there. So it's log to the base a of 3 squared, which is 9, plus log to the base a of 4 plus log to the base a of a. Just one point to note, it's really tempting to cancel all the logs that we can't at the moment, but you can't do that. You've got to get it as just log something before we can kind of unlog. Log to the base a of y is equal to, we just multiply these things. 9 times 4, which is 36a, log to the base a of 36a. Think about it as unlogging, if you like. The y must match with the 36a, and there we go. We've got our express y in terms of a in a form not involving logarithms. We don't involve logarithms. We're all done. That's your quick run through of logarithms. What I suggest you do now is go on to Coleman Web. You can use the end of chapter exam questions. There's one all about indices and logarithms in Core 2, or go through to the past papers, pick out Core 2 papers, and have a go at some questions. Best of luck to you.